Well, hi, this is Dr. Thomas, math instructor at Lawson State Community College, and in this presentation I'm going to show you how to find the minimum and maximum value of a quadratic function. Expressing a quadratic function in standard form will help us sketch the graph as well as find its maximum or minimum. However, if we are only interested in finding the maximum or the minimum value, then there is a formula that's available for doing so. So, in order to find the minimum or maximum value of the general form ax squared plus bx plus c, then we can use this formula for the minimum and maximum, which is synonymous with the vertex. So the vertex is the same point as the minimum or the maximum point. So we will use those terms synonymously. Notice the formula here. The formula is negative b over 2a comma f of negative b over 2a. So it's important that you realize that this is an ordered pair, and normally we write the vertex as hk. So this is the same thing as h comma k. Also, the first coordinate is always x, second coordinate is y. So anytime we are referring to x, we are referring to the negative b over 2a as well as the h. And anytime we're referring to the second coordinate y, we're referring to f of the negative b over 2a, which is the same thing as k. So recall that f of something is the same thing as y. Now let's do an example. Let's find the minimum and maximum value of the graph of f of x equals 1/2 x squared minus 4x plus 8. Here our a is 1/2, b is negative 4, and c equals 8. So if we were trying to determine what the minimum maximum value is, we would just plug that information into the formula. Now the x coordinate is h equals negative b over 2a. So we're going to plug in the information. B here is negative 4 and a here is 1/2. So once we simplify this, h is 4. The y coordinate is the f of negative b over 2a, and since we found out that negative b over 2a was 4, we're just going to plug that 4 back into the function, and that'll give us our y. So the function again is 1/2 x squared minus 4x plus 8. So wherever you see an x, we plug in 4 here and we get 0. So the minimum point is 4, 0. Now, why is it a minimum point? So note in the original function we have 1/2 x squared minus 4x plus 8. Notice that the 1/2 is positive here, so therefore our graph will open up like so. So the lowest point here will be the vertex, but also the minimum point. Now if I were to ask you what was the minimum value, it would be 0. And we'll talk about that a little later. Let's find the minimum or maximum value of f of x equals negative 3x squared minus 3x plus 1. Let's go ahead and figure out, do we have a minimum or maximum value? Now notice here that the a is negative 3. It is a negative number. Therefore this parabola will open down. Since it will open down, we have the highest point here called the maximum point. Alright, let's begin by finding the h. So h again, or x, is negative b over 2a. Our b was negative 3. So notice here that we already have a negative in the formula. So notice we have a negative in the formula here, which we brought down, but the b is also negative. It's negative 3. Divided by 2 times a negative 3, because a is also negative 3. Okay? And once you simplify this, and you can see that these 3's are canceled out, you still have a 1 at the top, so the answer is negative 1/2. Computing k, all you have to do is plug that negative 1/2 back into the original function, and we get 7/4. So therefore the maximum point is negative 1/2, 7/4. This is also known as the vertex. And the vertex form, if you wanted to plug it back in, the formula, and the formula again, let me just remind you, formula is f of x equals a times x minus h squared plus k. So if I plug this h in here, and I plug that 7/4 in here, and we already know that our a is negative 3 from the original problem here, that's our a, then we can just plug into that formula and we can get this standard vertex form here. Let's move on. Let's look at this function. F of x equals 4x squared minus 16x plus 1000. It says determine without graphing whether the function has a minimum value or a maximum value. Here the a is positive, therefore we should have a minimum value. Our parabola will open up. Since a is positive, therefore we have a minimum value. Alright, let's find the minimum or maximum value and determine where it occurs. So, if we only want the minimum or maximum value, and of course we have a minimum value, we can use the formula to find the minimum and maximum value. So the formula again to find that is negative b over 2a comma f of negative b over 2a. So all we're going to do is find out what negative b over 2a is, and then we're going to plug it back into the function. So let's figure out what negative b over 2a is. We have negative. B is a negative 16 divided by 2 times a. A is 4. Therefore, this negative times this negative is going to give us positive 16 over 8, which is 2. So we know that we have 2 for the x coordinate, and now all we're going to do is plug in this 2 into the function. So let's do f of 2 equals 4 times 2 squared minus 16 times 2 plus 1000. So that's 4 times 4 minus, what is 16 times 2? It is 32 plus 1000. Put that in the calculator. We get 984. So the minimum value is 984 when x equals 2. Okay, so let's try a problem from the text. Here's a problem. Let's look at number 78. Okay, number 78 is titled Maximum Profit. It says the profit P in hundreds of dollars that a company makes depends on the amount X in hundreds of dollars the company spends on advertising according to the model P equals 230 plus 20x minus 0.5x squared. What expenditure for advertising will yield a maximum profit? So they're asking for the maximum here. And since we already know the formulas for that, all we have to do is first figure out what X is, and then we can figure out what the profit is. So they're asking, what are they asking for? Are they asking for the X or the Y here? It says what expenditure for advertising will yield a maximum profit. So they're really looking for the X. How much money does the company need to invest in advertising to get the maximum profit? Okay, now that is written, notice that in this formula the equation is not written in descending order. So they have it backwards. So it would probably be best if you would rearrange the terms so that it will be easier for you to see what A, B, and C are. So let's rewrite it as P equals negative 0.5x squared. I always keep the sign that's in front of that term, plus 20x plus 230. So now we see that our A is negative 0.5, our B is positive 20, and our C is positive 230. For the X, we have negative B over 2A. That's our formula for the maximum or minimum value. So we're just going to plug in our B, which is 20, over 2 times negative 0.5. Negative 20 over a negative 1.0, which equals to 20. So our X equals 20. Now notice that the problem says that X represents hundreds of dollars. So since we have X is 20, it doesn't actually mean 20. It means 20 times 100. So 20 times 100 is $2,000. So they will spend $2,000 in advertising to get the maximum profit. They did not ask for the maximum profit, but I want to go one extra step to figure out how much money they will receive as a result of investing $2,000. So since our X is 20, what we're going to do is just plug that 20 back into the original problem. And it doesn't matter which one we use. We can use either or. I'm just going to use the second one just to stay consistent. Negative 0.5, and then whenever you're plugging something in, you can go ahead and just put a parenthesis. Okay. So I'm going to plug in the 20 for each X and do a little calculation. So we get 430, but if we'll go back to our problem, our Y is also in hundreds of dollars. The P is our Y. So the profit P in hundreds of dollars that a company makes depends on the amount X in hundreds of dollars the company spends on advertising. What expenditure for advertising will yield a maximum profit? So what we really need to do is multiply this 430 times 100, and we get 43,000. So the profit that they expect to make would be $43,000 if they would invest $2,000 in advertising. Well, that concludes this presentation on finding the minimum and maximum value of a quadratic function.